But it's time to actually start building circuits and programming. When we learn any programming language, almost always the first program we learn is a program called Hello World. Essentially, we get the computer to print out to the screen the words Hello World. With the Arduino, we don't have a screen. Instead, with a microcontroller like the Uno, we build a program which is generally referred to as Blink. Simply, it turns lights on and off. Now, before we can actually program the circuit, we need to build the circuit. And so I'm going to take you into Fritzing and I'll show you the circuit we're going to build, and then we'll build it on the board. For this, you're going to need 2 wires, 1 green LED, or orange or yellow, your choice, and you're going to need some resistors. The resistor we're going to use is a 220 ohm resistor, which has got red, red, black, black as its bands. Red, red, black, black. This will make more sense in a minute. So what we're going to do is we're actually going to take power from one of our pins on the Arduino Uno. And let's use pin 10 just because we can. We'll take power from pin 10 through a wire which will connect into this top positive rail. And I'm just going to plug it in here at the end because that's as good anywhere. And you can see how that powers up the entire top rail. We're now going to take our resistor and I'm going to connect it into one of those pins. And I'm going to take the other end and I'm going to plug it into, what did I plug that into? Into 7i. Now all of column 7 is now connected through that resistor to the Arduino. I'm going to take my LED. The LED has got 2 plates inside it. The big one is negative and needs to be connected to ground. The small plate inside is the positive lead. So I'm going to rotate that 90 degrees to make it easier to see. And I've got the small plate towards the top. I'm going to put the lead that connects the small lead into, what's that? That is 7F. And I'm going to pull the other leg across our gap and I'm going to put it in 7E. Now all we need to do is we need to take a wire from our Arduino to complete the circuit. Down here, there are 2 pins marked G and D. There's also a third one up here. Just for simplicity, I'll use one of these ones, but you could use any one of these 3 G and D pins. G and D is ground or 0 volts. So I'm going to connect from here all the way over to 7A. And I'm just going to make that a black wire so I can follow what's going on. On the real board, these are red and black on my board, so we can see what's going through. It's going to go from pin 10 onto the board, through our resistor, through our LED, and then back via another wire to ground. We could, if this was a more complicated circuit, we could move our wire to the negative rail and then use a third wire to join the 2 together. This is the sort of thing we would do in the future. Maybe that would be a green wire. So you can do it this way, or we can just, because it's a very simple circuit, just connect the black wire in. So let's jump to the actual circuit board and let's build it on the breadboard. So here is our Arduino Uno. Pin 10 is here. So I'm going to go into pin 10 with a red wire. I'm then taking that round to a rail on the breadboard. The resistors come on these pieces of tape, but they are actually color coded. In this case, it's red, red, black, black, brown. Red, red, black, black is the value, 220 ohms. the brown tells you how accurate it is. In this case, brown is 1%. We need to get it off here. Oh, and sometimes you might actually even see that on the tape, the actual value is written down. That may or may not be clear on yours, but if you think it's going to help, take a pen or a pencil and write on this tape 220. To actually use a resistor, we need to pull it off its stringers. These are reusable, so don't throw it away afterwards. We're going to bend its legs. I've got a special jig that will help me bend them reasonably straight, but it doesn't need to be. It doesn't need to be particularly neat. And we're going to connect it from that rail through to 7i. So 7i is there, and it may take a bit of pushing, and then connect it to that positive rail. So now it comes from down the red wire, through the resistor, and across into the board. Now we're going to take our LED. It can be a little bit hard to see, but inside there are two plates. There's a big plate and a small plate. If your LED is not bent too much, you will also notice that the leads are different lengths. The longer lead is the positive, and it's connected to the small inside. The shorter lead is connected to the big plate and is the negative. So I'm just going to bend this slightly, and it's going into 7. It would be if I wasn't dropping it. Going into 7F and 7E. And finally, we just need to complete the circuit, which goes from somewhere on that column 7 lower half round to a ground pin. That's the simple circuit. What we'll do in a moment is we'll change over to the Arduino and we'll code it. So now that we've built the circuit, we need to program the actual board to turn the LED on and off. For that, we're going to need the Arduino IDE. If you've not already got the software open it up now. And when you get there, you may need to do File, New Sketch, but you should have 2 blank loops. One is called Setup. Anything we put inside these 2 curly braces, the curly brackets, curly braces, will run once and once only. Anything we put inside the loop function between these 2 curly braces will run forever, or at least until you turn the power off. So we've got an LED connected to pin 10, and we want to turn it on and off again. As I mentioned when we were setting up the Arduino, talking about how the Arduino is structured, pins, the numbers, can be both inputs and outputs. So the first thing we need to do is inside Setup, we need to tell the Arduino that we want pin 10 to be output. So we press the tab key, we click inside the loop, we press the tab key just to bring it over here. The tabs don't really matter, they just make it easier to follow what's going on. And we're going to type the command pin mode. That's PIN capital M ODE. And then we're going to open parentheses or normal brackets. And you'll notice when you do that, the word pin mode goes orange. That means it's a function. And we get this hint up here. Now, this probably doesn't mean a lot yet, but the number in front tells us what type it's going to be and gives us a name. So this one wants a pin number, and then it wants to be told what mode. So the pin number was 10, comma, and then we want it to be an output. Now, with the Arduino and with C++ and many languages, you need to end any line of standard code, unless it's a loop, with a semicolon. So make sure you put a semicolon there. That's it for the setup. We now need to go into the loop. Again, I'm going to tab in. And what we're going to do is we're going to turn our LED, that's attached to pin 10, on, wait an amount of time, and turn it off again. So we're going to do what's called a digital write. Digital because it's going to a digital pin, write because it's going output. So it's digital write with a capital W in the middle. Again, this wants a pin and a value this time. So it's pin 10, and we want the value high. You could actually replace the word high with 1. You could also use the word true, but what we tend to do is we tend to write high because that's easier to read. High means we want a high voltage there, 5 volts, semicolon. Press enter. Now we want the computer, the microcontroller, to wait for a little bit of time. Microcontrollers work in milliseconds, thousandths of a second. So if we want our computer to wait for 1 second, well, that's 1000 milliseconds. So the function is delay, brackets, and as you see, it wants a long, something called a long, but it's got the value ms, which is a millisecond. So let's give it the number 1000. Semicolon. And now we need to turn it off again. So digital write pin 10, and the opposite of high is low. Could also use a 0, could also say false, but we'll use low for the same reasons as before. And then the last thing we need to do is make it wait again. Delay 1000, semicolon. And that's it for our first sketch. Now, you should be able to click up here to find the Arduino Uno board. If it says unknown board, look in the video for getting your Arduino to talk to your computer, but click on here and it should say Arduino Uno and it should give a COM port. To actually send this to the board, we first need to verify that we've typed our code right. So we press the tick for verify. It says it's compiling the sketch and our output window has got no bright shouty orange writing, which means it's all good. Moment of truth is we press the upload button and this will send the program from our computer to the Arduino itself. Now what we need to do is have a look and see if it worked. So here is our Arduino, and as you can see, pin 10 is connected, wires coming through, and our LED is flashing on and off once per second. It's not very exciting, but we've managed to get programmed the Arduino and it's talking to the LED. If your LED is not flashing, the first thing to check is that all the wires are nice and firmly pushed in. The second thing to check is to take the LED out, turn it round and put it back in. It's possible the LED is backwards. They will only work in one direction. Hopefully you've managed to get that to work and you've got it flashing. A challenge for you then would be to try and modify that blink sketch, and instead of it flashing on and off every second, get it to do the whole on and off cycle in 1 second. So on for half a second, off for half a second. See if you can work out the change that's required to make it go on and off in half a second. And I'll see you next time, now that you've got understand the basics of Arduino, and we'll start white belt properly, and we'll start with a bit more complex programming. I'll see you next time.